Today I'll talk about designing a custom controller. I was through writing this controller and I'm writing this controller which will go as a part of OpenEBS release 0.7, which will help in automating our storage pool to volume creation. A controller is basically a reconciliation process. It will watch for some objects, desired state, and then will try to drive through the it will watch through the actual state and desired state of the object, and it will try to move toward the desired state. And again, controller is level driven, it is not edge driven. So it means that it will watch for the resources, and it will watch for the state of the resources, and the state will be actual and desired. And if the actual state is not matching to the desired state, it will form a reconciliation loop to achieve this. And this object mentioned above could be native or custom. We'll see how we can extend native resources controller also. The pseudocode for the reconcile loop will generally look like this. So you'll have a desired state, again the current state, and if the state is, it will constantly try to make changes to move towards the desired state. So what we can do using a custom controller is this three more important things that I could figure out was like extending your functionality of cluster, and you can, as an application administrator, or if you want to deploy any application, you can easily automate its administration. And as well, you can extend the functionality of existing objects like deployment, stateful set, or replica set. You can extend their controller. So their controllers are, Kubernetes controllers are written in a very pluggable way, just to extend the functionality of the cluster and objects. So writing a custom controller, we should be knowing a few components that are involved in writing a custom controller. So the client Go components, we have reflector, informer, and indexer. These are the three crucial client Go components which are used in writing a custom controller. Reflector will talk to API server, and it will watch for the resources that you have registered, and it will list and watch for the resources, and will generally push to a delta FIFO queue. And the informer's job is to pop it from the queue so as to deliver to your custom controller. And finally, indexer is a thread safe store. So informer will be delivering the object along with events to your custom controller. And now you can store this object for later retrieval in this thread safe store, that is the indexer. We also have custom controller components. So following are the custom controller components that are more generally used to device one. You'll have to create an informer reference, indexer reference, resource event handler, work queue, and process item. These are the 5 basic components that will allow you to build your own custom controller by using reflector, informer, and indexer. Informer and indexer references will be just a reference to the informer and indexer, which will know how you can use this with your custom resource objects or maybe the native objects. Again, we have resource event handler. This event handler is a callback which will be directly fired by informer, and this informer will be firing this event handlers and as well dispatching the object to this event handler. And what we can do is, when we receive this object in the event handler, we can push it into a queue for processing the object or item, we call it. And that's why we have a work queue. So you don't want you to get overloaded with all the objects. So you can push your objects in a work queue, and later you can launch coroutines which will be consuming that queue, and you can perform your task based on the object status or whatever your use case is. But one thing that should be in mind, whenever we process a item, this would ensure that no two go routines would be processing the same object concurrently. This is how a custom controller and client go interaction will look like. We have a reflector here at the top of the screen. You can see it will be doing a list and watch, number one. Number second is you can register for the listing and watching whatever resources you want. At second, it will be pushing object to the delta FIFO queue. Third one is like popping the object by the informer, and additionally, it will then pass to the indexer. Indexer will store the object using the object and key. This is a thread substore. So to retrieve the object, you can use the corresponding key. Sixth number is dispatching dispatching object to event handler function. Informer will be dispatching object along with the event like add, update, or create. And then what we can do is take out the object and push it into a working queue and launch go routines, that is the 8th number, to consume from the work queue, process it. Ninth is get the object key, make your indexer reference, retrieve object from the store and process accordingly. So this is a typical workflow that will be almost same in all the pluggable controllers that we write, but the way we design our reconciliation loop or handling those events will depend on the use case. I'll take you guys through a quick code walkthrough where I'm writing a controller, and we'll see how we are registering the add, delete, or update event for a CR that can form the reconciliation process. And one more point to note is watching of a custom resource. You can watch a custom resource. We call it a primary resource, which can be used to manage your secondary resource. Now, secondary resource will be other application that will form a part of your application administration, like deployments or any other CRs again. So this my use case is like I will be having a primary resource, and the creation of primary resource or deletion or update will mark as an event so as to create my secondary resource or delete my secondary resource or update it accordingly. I will be taking through a code walkthrough. So you can find a fairly simple example at Kubernetes/sample controller. So I have this start.go file. This is just to build a kube client. Finally, the OpenEBS client, that is my OpenEBS resources, and Cube Informer Factory and SPC Informer Factory. Here we will be using new shared Informer Factory. What it will do is it will give you this indexer and store. It will return you in this Informer. Finally, you can instantiate a new controller. Let us just go through how our new controller struct look like. So this is the controller struct where you can use like client set, cube client set, and deleted indexer. So some of the features are there in Kubernetes/tool/cache, where it is defined which indexer or work queue you can use accordingly. Finally, this new controller will actually create a controller object which will be returning, and this is the informer event handler. This is of our main interest, this event handler. So we have add func, update func, and delete func. So whenever a custom resource that you have registered will get created or updated or deleted, the informer will fire this callback along with the object. you will receive the object. Now what you can do is whenever a add func has been fired, I have maintaining a queue load that is like key and operation. This is a structure, and I'm telling that just call the operation as a type of add, and I'm using enqueue object along with this queue. So this enqueue SPC is a wrapper function that I have written. Its job is to form a name slash namespace key from this object. So this cache dot meta namespace key func will take the object as an argument and form a name slash namespace key, and the key that is returned will be again pushed to this struct queue struct. And finally we will be adding this queue to that work queue. This is a rate limited work queue. Rate limited means if the work queue is full and there are not enough workers to consume the work queue, it will say to the informer, hey, just hold on for some amount of time. So going back to the handlers, one more important point to note here is whenever a custom resource that you have registered or a resource that you have registered is created, you'll get a created or added event. Similarly, for the update event, there is slightly difference here in the update event. You will receive update event in following three cases. Like when the object is updated, that means the resource version of object had changed, you will receive an update event. Or the object has been deleted. Even if you delete an object, you will receive an update event. And after every fixed amount of time, which is known as a resync period, you can specify your resync period. So after that amount of time, let us say my resync period is 20 seconds. So after every 20 seconds, a update event will be fired with the old and new object. So you can handle these things like what you want to do. If I want to only handle my delete event when I receive it, so you can check for whether this object that I received was scheduled for deletion, and you can mark the operation as delete. Similarly, you can compare between the new object and all object resource version, and mark as the thing that you want to do. For now, I have marked as ignore. I don't want to do anything. Similarly, if the resource version is same, that means update has not happened. So I'm ignoring this operation. And if the resource version has changed, that I'll mark it as a update event. And again, I will be enqueuing that into the queue. And delete function will also receive a event of delete. And one important point to note is whenever an object is deleted, you cannot generally fetch the object, right? So what you can do is, like, if you really require the configuration of your deleted object to perform certain tasks, you can use a cache indexer or delete cache indexer to store it for retrieval. So this is the way it works. Or you can directly hook in some handlers here only if you want to perform some actions for delete event. This is how we have registered it, and at every event we are trying to push our objects like in update, add, or delete. Finally, we can go to the start.go. So this was the controller that we formed, and then we will be calling controller.run. This will be actually firing workers, right? This will be creating workers to consume from the work queue and process accordingly. And this run receives threadiness as an argument. This threadiness will decide how many workers you want to launch to consume this work queue. Let us say 4, 5, or 6, some numbers. I'm using this run function to launch. We will go through a for loop to launch go routines here. So let us say if the threadiness count is 2, we will launch 2 go routines concurrently. And this run worker here, this is an infinite loop that will be constantly going on. It will again fire a function process next work item. Here what we are doing is, in this process next work item, we are getting the object from this work queue. right? So how do we get or push into the object? Will be again this Q algorithm of FIFO or kind of that. But one thing to notice is whenever you create a resource, let us say I created two resources, and the order in which it will be pushed into the queue by the informer, by the reflector there is not sure. So there is a random ordering whenever an object get pushed into the queue. So I'll receive the object from here. This get will actually reduce the size of the queue. Reduce the size means, let us say I had 5 objects in the queue, and if I do a get, that means now we are left with 4 objects in the queue. We'll have this this is an anonymous function where we are firing itself by passing the object downside, you can see here. And we can process our objects accordingly. And finally, if we are done, so this is the sync handler function. The sync handler will be the handler that will be actually firing your business logic here. Let us go inside this function to see how it works. So now you got the key from the queue, and now you pass that key to your function that will actually retrieve your object. So get species resource is the is the function that is retrieving my resource by doing a API request and passing on the key, that is the name, right? And if it is there, it will tell me your object exists, and it will return it, else the error will be handled saying that it doesn't exist in the work queue. Okay, so once you're done processing with your object, and now you are receiving the object and you know the operation type, whether it was add, delete, or update, you can hook in your business logic to do certain tasks, right? And so this queue, this work queue maintains 2 sets. One set is processing set, and the second set is dirty set. So whenever a object is pushed into the queue, it by default goes into the dirty set. And once a worker go and operates on that object, it will just go into the processing set. Now you should, when the worker's job is done, you should use this work queue dot done, else the worker will be engaged there itself, and it wouldn't release that item, right? So whenever a worker acquires an object, it tries to process the object, it will generally acquire a lock in it, so that no two workers are processing the object concurrently. So this work queue dot done is required even if your process failed. Let us say you wanted to do something after an add event and you retrieved it from the queue. Your worker was trying to do something and it failed. Even that you should be calling this work queue dot done. Now, if something has failed, you won't be doing this thing work queue dot forget. This marks as like when my worker was processing an object from the queue and it failed, and if we marked it as a done, then that object will again go into the dirty set. So again it will be queued. Okay, now if my process failed, what I can do is we will not use this, right? We will not forget it. And if everything was successful, we will just say, hey, go and forget this object, so that it is not again queued for processing. So this is the way we are using this rate limited queue that is inbuilt provided for you. Here is my handler dot go function, where this SPC event handler is fired from this sync handler that I was saying earlier. So you can just retrieve the object from the key, and you can pass on the operation, object, and the key to your handler function. Now you can actually write out your logic, how you can handle, like in the case of add, what I want to do, I can fire the function. This is the function that I've written for my own business logic. Here you can fire accordingly with this update and delete. Yes, so any questions till now here?
So Ashutosh, Amit here. So I had a question on the ignore.
Yeah.
If at all the resource versions are equal, do we need to enqueue it?
Again, Amit, I lost you.
If the resource versions,
Yeah.
right, old and new, are
Okay.
same, or yeah, that is what you have mentioned.
Yeah.
If the line number 114 is
Mm-hmm.
executed, right,
Mm-hmm.
then does it need to be enqueued?
Not really, Amit. You can ignore enqueuing here. Yeah.
Okay, yeah, thanks, Asutosh. That's
Yeah. Yeah. Yeah, I have just written this in queue at the latest section. So yeah, it will be in queuing every time. But yeah, you can ignore in queuing because if you don't want to perform anything on this part, you can skip this part. You can put on this blocks wherever you want to enqueue the object, right? Good point, Amit. Yeah. Any more questions?
Sutosh, are there any patterns to handle a scenario where um, this queue is in queue, or the queue object is first in, first out, right? Let's
Mm-hmm.
say uh, there is an object created, or like new CR is added,
Mm-hmm.
and before we can process it, it is deleted also, right?
Yes, yes.
So the create, we will still treat that as a create, and then but when we try to get the details, it is not there anymore, right?
Yeah.
Um, are there any standard patterns to handle this, or the code has to handle it?
Um, yeah. What one of the pattern that I could research on was when your like you the example you gave. Suppose my CR was created, I will go ahead and process that create request, right? And again, if we delete that object, I'll receive the deleted event. And once I receive the deleted event, I can again go ahead and process the delete business logic that applies there. Does this answer your question, Kiran?
Um, that is correct. So here I'm thinking, if the user has already deleted that custom resource object, we are going ahead and still creating a lot of resources and then deleting them. Right.
Yeah. So, yeah, right. But the controller will only know by the event. So if you have fired a event, that means it has received a create event, and it should ideally process that create event, right? Before deleting, it won't know whether how would the controller know that this create event I should ignore or I should not ignore, right?
Right. Before we start the processing, do we have anything in the status where we can set a value that I'm about to start setting, about to process this? Um, that way, we will know whether that object still exists. And if we are not able to set the status upfront that we are initiating the creation process, then we can probably abort it.
Yeah. This is a good point. But what if set up the status, let us say, to init, right? And after I set up the status, somebody go and delete the object again.
That's true.
Uh,
So every stage, uh, that's still very valid. So if after init, how do we clean up?
so for cleanup, right now, this I have not written the logic for cleanup. So I was thinking of that rollback feature of cast template. Or you can actually hook in your cleanup logic inside controller also, but for what I was writing involved all the processing to be done by the cast template itself. So I'm just firing my business logic to uh, apply those cast templates logic and reverse it if it goes wrong or things like that.
Okay.
Yes, so we need like more research on this part of cleanup or deletion. What will happen? Uh, I'm I'm doing it and will research and yeah, we'll come up with something.
Thanks, Asutosh.
Um, So this is how a controller will look like, and I'll just again go to the presentation. Um, some of the patterns that we need to follow is like you should operate one item at a time, and you are provided work queue interface. You can use this and operate items like launching go routines, acquiring a lock on the queue item, and doing things like that. So you really need not worry about locking and unlocking of the resources if you're using this work queue interface. Everything has been pre-written for you. What you need to do is just enqueue your object with proper key and focus on your business logic. So this is one of the great extensible uh, feature of this Kubernetes controller. Like you are just plugging in your handlers, right? And one more important point to remember is like a random order of resources in queue. So when controller will be queuing off your multiple type of resources, then there is no guarantee of ordering, right? So you must not take it for granted that what I have created 2 or 3 objects and it will go into the queue sequentially and follow your logic accordingly. So you can break your logic if you assume this. And whenever you receive objects from the caches, you are retrieving object from cache, please do not mutate it, because this caches may be shared across the controllers. So you would be breaking some other controller or yourself itself. One of the way to do is like making a deep copy of the object, not the shallow copy, and you can perform accordingly. And you can use shared informers, this reflectors and all that we saw in the diagram. So previously these reflectors and all were used to do watching, and then informer was used. And nowadays we are having this shared informer, so it will be building a reflector and all for you. So you really need not write the reflector functions interfaces. You do not need to implement. One of the interfaces list and what. You just go on, register your CR and fire and create a shared informer reference. That's all, and you are done. So these are some of the basic patterns that one should follow. Again, the kind of controller that you will be writing will heavily depend on your use case, but the 3 concepts remain same, like the events, receiving the 3 events, deciding on to perform on which events, and writing your actual reconciliation logic. So this is all what I could find and learn while writing this custom controller. Please feel free to provide me feedback and other things if you feel any. There are references that I went through. One of the simple example is github.com/kubernetes/sample controller. You can really go out and check how this controller logic is actually working. This is a very simple code to understand. That will be it from my side. Again, if you have any questions, please feel free to ask.
Thanks, this was very helpful.
Yeah, thanks.